Welcome back. Let's continue creating our base builder game. So where we left off last time is that we have objects such as this kitchen table here that now act as workplaces. And we can see that this worker is indeed transforming food into cooked jobs. It's going a bit fast, so let's see if we can pause it for a bit. We can see 3 foods, 7 cooked meals. Now there are 2 food, 8 cooked meals. And we can indeed see that this one is crafting 1 cooked meal at a specific location, this list location. So we have objects now actually doing something in the world. In this case, creating jobs for entities to perform. In particularly craft jobs that help you create new and probably more advanced items. These items are added to an entity's inventory, and they remain there. So what if we wanted those items to be somewhere in the world, perhaps, so somebody else can pick them up, but perhaps at some point in time, our entities will have a limited inventory that can fill up. So we should be able to take items out of the inventory and store them somewhere else. So what we'll do is we'll create a new job type, the store job, and this job will take an item stack from an inventory and place it somewhere in the world. And one constraint is that the target location should not yet contain an item stack. And the reason for this is that we can't have 2 item stacks on a single location. So if we don't add this constraint, then we might, for instance, override some existing item stack, and that's probably not the intended behavior. So let's get started. So let's start up Xcode. And let's open a project. And let's see. So let's start by creating a new job goal. In this case, the job goal will be to store an item stack. And well, we can try and build, but we'll get an error because we also need to give it a description. So let's quickly do that. So we have our store job, and that has an item stack. And we will return store the item stack.amount of a specific item stack.item.name in our world. So this should be enough to define our new job type. So let's also create a convenience function to create these jobs. So we will have a static function called create store item job, and this one will take an item, an amount, an integer, and a position. And this will be a vector. This will return a job, and we will return a job with the job call to let's see, to store an item stack. Let's create this item stack. This takes an item, that's the item passed in, and the amount passed in, and the target location will be the position passed in. And we won't add any requirements just yet. We'll do that as we go and start adding some tests. So let's go to our job tests and create a place for our store jobs. And let's start by the first test. Let's simply test if the store job performs the intended behavior. That is, taking something out of an inventory and moving it somewhere else. Let's create an item to store. This will be an item, just a name. Let's create an entity. This will have a name and a position. And let's make sure that in the inventory we have the item to store, and let's say we have 7 of these. And let's create a store job. So our new job type, we use job create store item job, and the item will be the item to store. We will, let's say we store 5 at position 0, and let's push this job onto the job stack of the entity. Then we need a world, and we can update our entity in this world. And then we can start asserting something. So the first assertion we'll do is we'll assert that the entity in the inventory for the item to store now only has 2 left instead of the initial 7. Also, I'll make this a throwing test function, because then I can use the stored item stack. Then I can use the xav unwrap function to find the items in this position. This returns an optional, and this unwrap function either fails the test if it and the optional is nil, or we get back the actual item stack. It makes it's a bit less writing code than using something like a guard let or an if let statement. So let's see. So now we are stored item stack.item should be our item to store. So this item stack should be the items that we want to store, and we should also, the amount should be 5, because that's what we defined here as well. So let's see if this test at least runs. And the test fails because we still in the inventory have, for instance, 7 instead of 2, and there are no items in the world. And that's because we haven't written any code to resolve store job yet. So let's go to our entity, and let's look at where we are resolving the let's see the check requirements. Let's see where we're completing the jobs. We should add another case for store jobs. We'll take out our item stack. We'll make sure that we pop the job when it's done, and we should have a function that let us store an item stack somewhere in the world. So let's go to our job completion handlers and implement a new private function store. This will take an item stack, and this will take a world. This is where we need to store in. And let's see. So let's first see our current inventory amount for this item is inventory for item stack dot item. Then this should be more than what we requested. I'm using the assert function here because in a debug build, this will pause the program, showing that this somehow wasn't valid, and this is something that should always be valid if you are creating the jobs correctly. However, in a release build, this only provides a warning, so it won't crash the app. So if, for instance, somehow the inventory amount is less than what we requested on production, somehow we create some out of thin air, I think that's less of a problem than the program actually crashing, but especially during the development, I would like to get an error message once this assumption isn't valid anymore. So let's update our inventory. So we have our item stack dot item, and the amount that we now have is the inventory amount minus the item stack dot amount, and the world will have the new item stack at a position. And we can do this because we assume that only empty positions in the world will be used for this for store jobs. So let's see what this does for our test. Let's go back to our job test and run the test once again. And now the test succeeds. What we also just said is that only at empty locations can we store items. So what if we create a test for a store job and say it fails at a location with an item stack? So that's a pre-existing item stack there. So let's see. So we have an item to store again. And we have again an entity. Let's see if we can try and copy some stuff here to save us some time. So our world should have items at position 0. It should have a pre-existing item there. So let's create a pre-existing item. So item pre-existing item, and this will be an item stack with the pre-existing item, and let's say we have 100 of those. And we're missing a label. So this should now be okay. So we also have our store job. We push the job on the entity stack, and we're updating the entity in the world. Now let's try and assert something. So let's assert that we still have 7 in our inventory because the store job should fail. So let's take our entity dot inventory dot for the item to store, default of 0, and this should still be 7. Also, let's assert that if we look at our world, at the items at the 0 position, the item should still be the pre-existing item. It should not be overwritten by the item to store, and the amount would still be 100. So let's see if this test fails. It should, because we have indeed we only have 2 left instead of 7. So that means we did store, and the at the location we have now the sum item, that's the item to store instead of the pre-existing item, and we have 5 instead of 100. So we're obviously not checking for any the tile should be completely empty requirement. So let's create a new requirement, and we will call this requirement no item stack, and it doesn't need any additional parameters. It should just say that we need an empty item stack. And let's go into our entity where we are doing our requirements checking. So let's create a case for the no item stack, and let's just make sure that if the world items at the job.target position is not equal to nil, then we will return false. And let's go back to a test. And let's see, our test is still failing. And again, just to make sure, because sometimes the compiler doesn't immediately fix, is it immediately taken into account when you run the test. So what's going wrong? Well, I think we didn't add the new requirement to our job yet. So let's create a new requirement. And this will be a no item stack requirement. So let's run our test again. And now the test passes. So our new requirement is implemented correctly. So let's do one additional requirement, and I want to make sure that you are at the correct location as an entity to store a job. So you need to move to the location where you're going to store the job to be able to fulfill the job. And if that doesn't, if you're not at the right position, you should the entity should spawn a move job. So let's create a test for that. So let's create a test for the store job at the wrong position. Spawns a move job. So again, we need an item to store, and we need an entity, and we need some items in the inventory. We again need a store job. Let's create a store item job for the item to store. Let's again say we need to store 5, but this time at a slightly different location. Then we push this job onto the entity's job stack. We need a world. And we need to update our entity in this world. And now we can start asserting something. So first, let's make sure that our entity's inventory for the item to store still holds 7, because I assume that we now have a spawn job and didn't resolve the store job yet. So let's see if our if the job on top of the stack is now a move location job. So let's see, try and get our top job. The unwrap entity jobs.peak, because that returns an optional. And then we can make sure that this is a move to a location job. And if it's not, then we will fail the test. Expected a move to location job, but got something else. And if this is successful, then we can assert that the top job's target position is indeed the location where we want to move to. So let's run this one. And it fails again because the store job gets resolved because we haven't yet added a position requirement to the job. So when we create the job, then we also add a position requirement here. And if we now go back to our test, let's run it again. The test succeeds. Now there's one thing that is bothering me when we look at the entity where we're checking for no item stack. We're checking whether there isn't any item stack in world at a certain position. But what if there's an item stack, for instance, that has some item and the amount is 0. So this is a valid item stack. And I think we should consider an item stack like this to be a valid location as well. So I think we should change this test a bit. So first, if the existing item stack is, if there is one, world.items at position job.target position, then we can check return the item stack, but amount is not equal to 0. Because if it is 0, then we don't want to return false. Does this work? I don't think so. I think we need to be a bit more specific. So if our existing item stack is not equal to 0, then we return false. And in any other case, we simply continue the other checks. The item stack dot amount. So if it is 0, then indeed we can simply continue. And if it's not, if there isn't any existing item stack, then we simply also continue. So this should still satisfy this test, but it takes care of an additional situation. And we can even make sure that we have a test for that one as well. What we'll do is we'll copy this test. And we say this one, store job succeeds at the location with a 0 item stack. So let's create all this existing stuff. We have the pre-existing item, but the amount will be 0. We will do the update, and this time we can assume that it succeeds by having only 2 left. After we should have the item to store here now and 5, because that's what's in the job. And let's see if this succeeds. This passes. And let's see if all the other tests pass as well. That's also good to do. I wanted to say every now and then, but you should actually do it all the time. Okay, I think that's enough for this. So we now have our store job. The next time we spawn store jobs when crafting. So when crafting succeeds and we have a certain amount in our inventory, then we will create a spawn job. That's it for now. Thanks for watching and have a good day.